Hello and welcome to lesson 2.2, the length of a line segment. And right here, what we can see in front of us, this is actually the length of a line segment formula. I've included a Khan Academy video kind of explaining how this formula comes around, but really it's just the Pythagorean theorem. But they do a really good job of explaining it, so I figured I would let you watch that and take a break from hearing my voice for once. All right, so what we are going to do here in this video is we're going to take a look at this question here because this is one of the tougher questions that you can get. If we have just 2 points and we want to know the distance between it, we'll just use the distance formula. X2 minus x1 squared plus y2 minus y1 squared, and take the square root of that, and that's your distance. This is a tougher question, though. So, our example, find the distance from a point to a line. So we know that the shortest distance between any 2 points is a straight line. So here's what we're going to do. We're going to determine the equation of the line which is perpendicular to the given line and which passes through point P. Now, what we're going to do, we're going to find the slope of the given line. So y equals x plus 5. You'll see that our slope in that case is going to be 1. The next step will be we're going to take the negative reciprocal of the slope of the perpendicular line. So all that means is, hey, the slope of the line that's perpendicular to right here, this line here, so the one that intersects it at a 90-degree angle, is going to have a slope that's a negative reciprocal. Negative reciprocal just means we take the slope of the given line, we're going to flip it around and put a negative sign in front of it. So, for example, I'm going to just pop over here before I get into this question here. If I know the slope of my given line is 2, comma, then the slope of my perpendicular line is going to be, we're just going to flip the 2 over, pretend that's a 2 over 1 as a fraction. We're going to flip that over. It's going to become 1 over 2, and it's going to be negative. So it's going to be negative 1 half. Another way of looking at this is if I know, and I've got to use my equation here so I can get proper fractions. If my slope, say, is 5, let's say my slope is 5. Well, 5 is the same as saying 5 over 1 as a fraction. We don't ever write it like that, but it makes a little bit more sense for understanding the reciprocal. The reciprocal just means, hey, what we're going to do here is the numerator is going to become our denominator. The denominator is going to become our numerator, and we have to make it negative as well. So it's going to be negative. And then let me just go. Sorry, I should have done that first. So 5 over 1, the reciprocal is just going to be negative 1 over 5, the negative reciprocal. And that's going to be the slope of our line, our perpendicular line. So that's just showing you how to find a negative reciprocal. We're not going to worry about that right now. I deleted the wrong thing, but that's okay. I'll put that back in. Okay, so just going back here, we'll take the negative reciprocal of the slope of the perpendicular line. And we're going to use P in the perpendicular slope to find the equation of that line. So that's what we're going to do. I'm going to show you how to do that using this example right here. But once we've done that, so we found the equation of the line, that's great. We're also going to find the intersection point between the two lines. To do this, I strongly recommend using Desmos, but you can use any of the other methods that we've learned to solve a system of linear equations. So once we've found that intersection point, we're going to use P in the intersection point to calculate the distance from P to the given line using the distance formula. So what we know for this example, well, we know we have a point, negative 1, 3. So I'm just going to come back here. Our point P, we'll call it P for point, negative 1, 3. Perfect. We also know the given line, and the given line is y equals x plus 5. Y equals x plus 5. Perfect. So in this case, we have to say, hey, what is our slope of the given line? Well, remember, we write our lines in the form y equals mx plus b. If there is no number in front of the x, no coefficient in front of the x, it's a 1. We always have ghost 1s in there. So in this case, there's no coefficient in front of x. That means our slope is 1. So the slope of the given line equals 1. Or another way to put that is if we put it as a fraction, it would be 1 over 1. And the reason I'm going to do that is I'm now going to find the slope of my perpendicular line by taking the negative reciprocal. So slope of the perpendicular line is equal to the negative reciprocal of the slope of our given line. So 1 over 1, when we flip it, is still 1 over 1. So it's just going to become negative 1 over 1 or negative 1. So we know the slope of our perpendicular line. We also know that the point, negative 1, 3, is on that perpendicular line. So we're going to use that. We're going to put this into our y equals mx plus b format, but we are going to use the coordinate points. So negative 1 is going to be x, 3 is going to be y, and we know our slope is negative 1. Here, let me just highlight this into a different color. So we know that's the slope. We're going to use these points here for our x and y to find the equation of the line. And you may want to know why we want to find the equation to a line. Well, the reason is we want to find the equation to the perpendicular line because we need to find the point of intersection. And then we can use the point of intersection to find the distance between our given line and the point negative 1, 3. Excuse me. So instead of 3 here, instead of y, we're going to have 3 equals our slope, or m in this case, is negative 1. And that's going to be times our x from the coordinate point, which is negative 1, plus b, our y-intercept, and we do not know what our y-intercept is. We're going to use this to figure out what our y-intercept is. So negative 1 times negative 1 is going to be positive 1. We want b all by itself, so when that positive 1 comes over to the left side, it's actually going to be negative. So we're going to have 3 minus 1, or 2. Here, actually, let me do this. 3 equals 1 plus b. Negative 1 times negative 1 is 1. 3 minus 1 equals b. And so we know 2 equals b, or b equals 2 in this case. So the equation of our perpendicular line, the line perpendicular to the given line that runs through the point negative 1, 3, is going to be y. Here, actually, let me change the color. It's going to be y equals our slope, -1, x plus 2. Great. Now you're probably saying, how's this going to help me? How am I going to be able to use this information to find the distance between the given line and that point? Well, my simple answer to you is let's use Desmos. We need to find a point of intersection. We're going to use Desmos to find that. So, okay, we're going to come over here. Oh, Desmos. I've got it almost lined up there. Perfect. We're going to put in our two equations. Oh, sorry. Y equals x plus 5. That's my first one. Y equals x plus 5. Perfect. And then we have y equals -x plus 2. Great. And now all we need to know is what's our point of intersection? Well, our point of intersection is -1.5 and 3.5. So let's write that down, -1.5, comma, 3.5. -1.5, comma, 3.5. Perfect. Don't need to bold that, so I'll just take the bolding off. So really now we've got 2 points. We just have to apply our distance formula in order to figure out the distance between our given line and this point. So let's do that. Our point that was given to us in the problem, our point P was -1 and 3. I'm just going to bring it down here so it's still on the screen. So now what I can do is I can use my wonderful distance formula. So I'm going to say D for distance. Oh, let me just change that back to black font. There we are. D. Okay, never mind. We'll leave it this way. D is going to be equal to the square root of, in brackets, x2 minus x1. It doesn't matter our order because we're going to end up squaring it. Here, that's going to actually... Whoop. All right, so bracket, let's take -1.5 minus -1. And that's going to be squared plus, we're doing the same thing for y now. So set it up there. Bracket our y, 3.5 minus 3, and that's going to be squared. Perfect. So when you're doing this, remember your order of operations. So I'm just going to get this started again. Equations right here. D equals, we still have the square root. Can't forget that. And this is going to be squared. So let me just bring that up. All right. -1.5 minus -1. So that's -1.5 plus 1. We're going to get -0.5. And that's going to be squared. And really, really important here, that negative is all a part of what's going to get squared. So we are going to get a positive number. So bracket 3.5 minus 3 is going to be 0.5. Once again, that's squared. So let's just grab this. It's going to be squared. And so now we've got -0.5 squared. So when we do that, we should get 0.25 plus 0.25, and we're going to end up taking the square root of that. So let's just put that in here. Insert our equation. D equals the square root of negative 0.5 squared is going to be 0.25. 0.5 squared is going to be 0.25. So we're going to add that up. You're going to get D equals the square root of 0.5. So when we take 0.5 and we find the square root of it, we're going to get that D equals 0.707, but I'm going to just round it to 0.71. So that's how we go through and we find the distance between line segment, point in an equation. Step one, so let's just review this really quickly. This was our point. This was our given equation. We knew the slope of the given equation was 1, or 1 over 1 if we wanted to put it as a fraction. So the slope of the perpendicular line must be the negative reciprocal, which just means that we flip the fraction of the slope of our given line and put a negative in front of it. In this case, that would still be 1 over 1. It's just negative, so our slope of the perpendicular line is negative 1. We use that slope and the point to find out what our y-intercept is or find out what b is. We put all that information. 3 comes directly from the point P. We use 3. We use negative 1 as our slope, and then negative 1 is our x as well. Solve that, we find out what b is. Once we've got that equation, we go and we find the point of intersection. So or another way of saying that is find the solution to the system of linear equations there. So we did that. We found the point of intersection. We used Desmos to do that. If you need a refresher, there it is. We put both equations into Desmos, went to the point. Perfect. That's our intersection point. Now we have our 2 points. We're just going to apply the distance formula in order to find the distance between those 2 points. That's probably the most complicated one that you'll come across. Hopefully that video was helpful, but if you do have any questions, as always, feel free to contact